All right, let's talk about mass and matter. So, does it really matter? No, just kidding. All right, so matter is anything that has mass and takes up space. Mass is the measure of how much matter there is. These are kind of circular definitions. Matter has mass. If it has mass, that measures how much matter there is. Okay? And so when you hold something, some things we feel are heavier. More massive objects, as we're talking about here, have more weight. Okay? So this board game, oh, this is a little bit heavier. Or this book, oh, this gets really heavy, right? These are heavy hardcover books. More massive objects, massive, having mass, have more weight. Earth's gravity pulls on those things. They're getting pulled downward towards the earth, okay? And so the more mass they have, the more weight we experience when we lift them. This pencil, wicked light. My camel, wicked light, okay? It's just made out of like balsa wood or something, okay? So there are some things that are light. Less massive objects have less weight, okay? But anything that has mass and takes up space, we call matter, okay? And if we measured its mass, that would tell us how much matter there is, all right? More massive objects resist changes in motion, okay? This is called inertia. So if you think about throwing a tennis ball, you can pick up a tennis ball and you can huck it really far, okay? But if you took this bowling ball, which there's a 12 on, means this is a 12-pound bowling ball, you might need two hands to throw it and you wouldn't be able to throw it very far. They resist changes in motion, okay? A tennis ball, tennis players hit these over 120 miles an hour. Bowling ball, you might roll it like 20 miles an hour, okay? You're not bowling a ball with as much velocity as you're able to hit a tennis ball because it resists change, okay? So inertia is the resistance to change. So we have a few ideas here, 4 words: matter, mass, weight, and inertia, okay? So inertia, okay, things that don't want to move, they don't want to change. Typically, if you have a lot of mass, which means that there's a lot of matter there and it would have a lot of weight, it resists changing, okay? But if you are lighter, if the matter does not have a lot of mass, then it's not going to be super resistant to change. And so it won't have a lot of weight and there won't be a lot of inertia, okay? So what do we talk about? We measure mass in kilograms, all right? So originally, a kilogram was based on the mass of 1 liter of water. So 1 liter is basically like an Nalgene bottle. A quart is basically a liter. If you get a soda bottle, that's 2-liter bottle, okay? So it would weigh 2 kilograms, okay? So if you look at how much different stuff weighs, okay? 1 liter is 1 kilogram. A cat, approximately 5 kilograms. A person weighs approximately 55 kilograms. And a motorcycle weighs approximately 200 kilograms. And so when you're measuring these things, there's a whole wide variety. But this gives you a nice little ability to guess how many kilograms something might weigh. Okay. So there's a huge range of masses of objects in our universe. You can see that an electron is really, 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 really light. Okay, it weighs almost nothing. And that's why it says 9 times 10 to the negative 31st. Okay, that means 0.000000000. There's going to be 30 zeros before that 9. 0.0000000 30 zeros, and then a 9 is how much 1 electron weighs. And then you have an atom. Mosquitoes weigh 1/100,000th of a kilogram. Okay. The pound is just about half a kilogram. A person weighs about 70 kilograms. A car weighs about 1,200 kilograms. You can see a plane here. The Earth, that's 6 with 27 zeros after it. Okay. These notations are scientific notation. We'll look at that in a second. Okay. The Earth, the sun, and the entire galaxy weighs 10 to the 40th kilograms. That's a 1 with 40 zeros after it. Okay. huge, huge number would be the weight of the Milky Way, or the mass of the Milky Way galaxy. So in order to be able to talk about everything in the kilogram, rather than using centigram and decigram and just gram and all these other measurements, if we want to put everything in kilograms, we need to be able to account for this wide range of really, really light things and really, really heavy things all in one place, okay? And so we use scientific notation. So we're in base 10, so we always use a base of 10 here. And this is any number. It's got to be 1 or higher, and it goes up to like 9 point whatever you want, okay? Up to 10, but not including 10. And this is counting how many decimal places we want to move it, okay? So this 3.8 times 10 to the 8th says you take 3.8 and you move it 1, 2, 3, 4, 5, 6, 7, 8 decimal places. Or if you're converting the other way, you would say, oh, well, I need to get it right after that first digit. I always get the decimal place right after the first digit. In this one, I would have to move it 1, 2, 3, 4, 5, 6, 7, 8 places. And really, every time I move it this way, I'm dividing it by 10, 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 dividing it by 10. And I divide it by 10 eight times to get to 3.8. And so if I want to get back up to this giant number, I need to multiply it back by those 8 tens. And so we call it 3.8 times 10 to the 8th. Because every time I multiply by 10, it would become a 38. And now I would have times 10 to the 7th. And then I multiply by 10 again, and it would be 380 times 10 to the 6th. And I can multiply by another one of those 10s and make it a 10 to 5th. And that keeps moving the decimal place back over. Okay? Notice if you have a really, 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 really small number, 2 times 10 to the negative 9th, we start out with 2 and the decimal's right here, and we need to move it backwards to make it smaller. Negatives make things smaller 9 times. It doesn't make it into a negative number, it makes it into a decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9 places. And we put a 0 in front just to show that place value. Okay, so 0 point, and notice there's 9 decimal places here, so it's really only 8 zeros before the 2, whereas this is 8 places after the 3. Okay, so we're going to practice converting and using scientific notation, and then we will be doing a mastery check. So good luck and farewell.